Good morning. I'm going to be talking about how we could use spatial features of human settlement to try to predict epidemic patterns. My name is Sanya Rahman, and I'm a graduate student from Makerere University in Uganda. I want to acknowledge that this work is very much inspired by the work of Dr. John Quinn and also Dr. Martin Mwebaze and also Ernest Mwebaze, doctor. Therefore, I hope to become like them when I grow up. I also want to state that this work is still in its early stages. I'll be sharing with you the ideas of what we want to do and how we intend to do them, and then also look at a few provision results that we have actually attained. So we'll start by looking at the problem. Looking at that image, probably you'll see that some bubbles are actually larger than others, and that image illustrates the distribution of TB disease in Uganda in the year 2013. We can derive about 3 problems from that kind of distribution of disease. For those who are familiar with Uganda, you will realize that the larger bubbles actually are around regional cities. We have regional cities, Gulu in the north, and then we have Lira also in the north. In the central region, we have Kampala, the capital city. In the west, we have Masaka and then Mbarara. So clearly, you can see that the distribution of disease happens to be larger in around urban centers than rural areas. Where you have smaller bubbles, those represent smaller urban areas. Now, the literature from elsewhere also shows that actually certain types of settlement tend to catch disease much faster, and also they tend to recover much more slowly after an outbreak. So the question we ask is, why is that so? That certain kinds of settlement tend to have those characteristics of epidemics. Here we have another image illustrating also movement of people between the cities that we talked about. And you can see clearly that the connectivity tends to be higher between larger cities than also smaller urban centers. So the goal of our study is, or the project is just to understand how settlement characteristics implicate those observed epidemic patterns. So we selected about 5 features, which include extent of urbanization of a given settlement, its spatial accessibility, and then mobility flux between the settlements, and then the connectivity, and also the population density. Now, in this talk, I'm going to be talking about urbanization specifically, and we look at we classify settlements into 2 categories, urban ones, and then we have rural settlements. Up there, we have a typical urban settlement in a developing country, and then below that, we have a rural settlement. So the question I want to try to ask here and answer is whether there's any relationship between the kind of settlement as well as a spatial epidemic distribution. And then secondly, how best we can investigate any potential relationship between epidemic distribution and the kind of settlement that we're looking at. Now, our area of study, we selected 4 contiguous local area administrative 4 units Local administrative area level, local administrative unit 4 levels are equivalent to what we call sub-counties in Uganda, which have combined population as stated up there and the combined area of that. Now, since we're going to look at the spatial features of a settlement, we also considered the land use in the study area. And our chosen area of study has mostly built up area, and then it has bare soil, and then you have vegetation and water as the land cover. We considered 3 sources of data: satellite imagery, that's from Landsat, 8 from USGS, using all 11 bands. We collected all 11 bands, but of course we use only a few bands and try to select the best resolution images at 30 meters spatial resolution. We also consider the use of geospatial data, that's OpenStreetMap data, which we got from GeoFabric. And then finally, of course, the disease data, that's HIV and TB. Now, the general approach we have used is first to map out settlements and then also to quantify the amount of urban in every settlement. And then the next thing is to classify settlements into either rural or urban. And of course, we use a simple definition of urban, which is a place dominated by the built environment. We're aware that there are many definitions of urban, for example, just by using boundaries, also by using the population size. However, here we use the definition that involves the use of the built environment, which is consistent with the kind of data that we also use for the study. And then the third step is to try to model the relationship between urban concentration and disease dynamics. Now, to extract the built-up footprint in our area of study, we computed 2 indices. One is what we call the normalized difference built-up index, and then correspondingly, we have also the normalized difference normalized difference vegetative index. So on the left-hand side, we have the NDVI map, and then on the right-hand side, we have the NDVI map. So to extract the urban footprint, you simply subtract the NDVI map from the NDVI map. And the result is what we have on the right-hand side. So what we did is simply to translate from the false color map that you see on the left-hand side to get the built-up footprint on the right-hand side. So on the right-hand side, we have the white pixels represent the built-up area, while the black ones represents everything else from vegetation to water and basically vegetation and water. Now, the white pixels represent built-up area as well as bare soil, because in the analysis, you find that the 2 land covers, both built-up area as well as bare soil, have similar spectral characteristics. On the right-hand side, we have a scatter plot, which shows the distribution of disease cases within the study area. But this data is picked from one health facility, that is Mulago Hospital, the National Referral Hospital. So you can see that the pattern it takes is kind of similar to the pattern of the built-up space. However, this is only data from one health facility. And of course, we intend to collect data from all over the country, from health facilities, and put it together and then see how we can be able to model the relationship between case distribution and urban concentration. Now, another thing we want to do is to integrate road network data. Because you can see from this image that within urban areas, the road network tends to be much more denser than in rural areas. So we think that we can use this road network to improve the mapping of the built-up area, as well as to help us with downscaling population data to lower spatial units. Now, what we intend to do from here is actually, the bigger picture is try to build a computational model that can take all these features, including mobility and then accessibility, urbanization and so on, into one computational model, and then to be able to use that to try to predict epidemic patterns in coupled populations. So how we intend to relate the features that we have extracted with epidemic processes is by use of mutual information. Mutual information simply can be defined as, it's borrowed from information theory, and it's used to measure the relationship or dependence between random variables. So this framework will be used to relate features to epidemic properties. And then also we want to, the analysis will involve extracting coupled populations. Coupled populations are linked by movement of people between settlements. So the idea here is to extract coupled populations from the mobility network and then see which settlements are actually interlinked or linked with each other through mobility of people, and then be able to undertake analysis between pairs of nodes or places. How we intend to relate epidemic properties between two settlements is using a simple process. We believe that two places or two settlements are likely to have similar epidemic properties if they share neighbors. If they share neighbors, and then also if they have a direct link between them, and then also if they have comparable spatial features. And then that is built into a simple model whereby we have our measure of similarity, which is phi, and then this row here represents any of the features that we are looking at. So if two settlements have similar epidemic properties, then they should be able to have, we should get the value of phi should be 1, and anything apart from that should be less, phi should be greater than or less than actual 1. So it's still too early to draw any conclusions, but however, the vision here is to be able to engineer features from the different characteristics of settlements that we have talked about and build that into a framework that we can use to predict epidemic properties in coupled human populations. So basically that's the idea of this study, and I'll be glad to welcome any questions.
Thank you very much for your presentation. My question relates to your rationale of what you're doing.
Yeah.
Because spatial settlement features by themselves are not responsible for epidemic. There are other underlying factors that lead to the epidemic and not necessarily the spatial features. Because you can have the spatial features and there's no epidemic.
Yeah, true. Spatial features are not directly responsible for spatial spread of disease. But what we're doing here is to look for proxies. We're looking for proxies that actually correlate with epidemic patterns. Say, for example, if you take movement of people. Yesterday someone talked about that everywhere we go, we actually carry disease with ourselves. So can't we use the movement patterns of people to be able to predict whether or not a disease will be spread from one place to another? So that's basically what we're trying to do. And the idea here is that most modeling of disease uses population data. So we're saying that, and we know that censuses are normally performed over a period of, say, 10 years. But in the absence of, say, census data for modeling, can't we use other sources of data to be able to do the same thing that we have been using, trying to do with actual population data? Yeah. Yes.
My question is in regard to your definition of urbanization.
Yeah.
I want to know. Yeah,
My question concerns your definition of urbanization.
Yeah.
You said you collected some data. I don't know whether you first defined what urbanization is, then you collected your data according to definition, or you first collected your data and then you decided to define urbanization in that way. And I'd also like to know whose definition is it, or which dictionary did you use, or which reference can you give for that definition of urbanization?
Okay, as I noted before, we have different definitions of urbanization. Most urban definition that are used involve looking at population. For example, in Uganda, they look at how many people live in a particular settlement, and then they're able to designate that place as urban or rural. And then another definition involves the use of boundaries. Why I chose this particular definition is because it's consistent with the kind of data, because it's very easy to extract the built-up environment from satellite data, which is much more difficult. If you say, for example, when you say Arusha is an urban center, it becomes very difficult for you to be able to tell where actual people live. But by being able to identify the built environment, then you can be able to know exactly where people are located. Now, that definition is taken from the literature by some author called Potere and also Snyder. So that's what we actually use. So it's not directly from a dictionary. And then secondly, whether I first chose to collect data and then look for a definition or vice versa. Of course, I considered the options that were available to me. The use of existing data sources, for example, population data, and then also satellite data. So I realized that because we want to model disease transmission over shorter periods of time, so using population data will be actually not suitable. So I settled on the use of satellite data, and then also looked for an appropriate definition of urban. Yeah.
I will take one more.
Thank you for the nice presentation. I just want to know the significance of classifying the settlements into rural or urban. Is it in any way related to the spread of disease?
Why we want to classify? Because we want to see whether the nature or the kind of settlement has a relationship with, say, the speed at which it catches disease, as well as the prevalence, say, of a particular disease in that area, as well as with how quickly the settlement can recover after catching, say, an infection.